Hello everyone, welcome back to Xcoding with Alvian. In this video, we are going to build an app icon generator Swift command line tool for Ubuntu Linux and macOS. In the previous video, we have successfully built the SwiftUI App icon generator targeting the iOS as well as the macOS catalyst. In this video, we are going to continue to build this app icon generator as the command line tool. So this will be available on Ubuntu Linux as well as macOS without depending on the UIKit platform. We are going to use some open source library such as LibGD to resize the images, and we are going to also use the Apple Argument Parser to build our command line tool. So without further ado, let me just show you how the command line tool works. So here in this Ubuntu virtual machine, let me open my terminal, and this is the project where the command line tool is located. Let me go to the release and invoke this app icon gen. And like the other command line tool app, when we pass this help argument, help flag, it will provide the overview as well as how to use this CLI tool. So it has two arguments, the input image path as well as the export path to save the zip. And for the options, we have all iOS, iPhone, iPad, Mac, and Apple Watch to export the assets to. Now let me try to run this. I already have an image in my directory here. Let me delete the previous app icon zip. And let me run this. So I need to pass the input image path as the first argument. And for the second argument, it should be the export path where the zip will be saved. I will save it in the current directory. And let me also pass all, so it will generate for all iOS, Mac, and Apple Watch. Okay, as you can see here from the printed console, it add the app icons for Watch, iOS, as well as Mac. Now let me open this inside the documents, app icon gen. This is the app icon zip. Now we have three folders, iOS, Mac, and Apple Watch. And inside this, we have the app icon set containing the contents.json as well as all the icons for each of the platform. Okay, this is how it runs on Ubuntu. Let me show you how it runs on macOS. This will be very similar. Okay, so here in the build also, I can check for the help on how to use the CLI tool. And here I already also have the icon PNG in my directory. So I will pass that as the input image file. And for the export path, let me pass this desktop, my desktop. Okay. Here in my desktop, this app icon zip is generated from this command line tool app. Let me unarchive it and let me open. Okay, it has all the folders containing the app icon set that we can just use, and we can drag and drop this to an asset in an Xcode project. Okay, so that's basically how the command line tool works and what we will build in this video. And in this video, we are going to use this Ubuntu Linux to build the app instead of using Xcode, because I want to show you how the current state of Swift development in Ubuntu. In case you are wondering how I run Ubuntu in my Mac, So there are several options that you can use, several virtualization software such as VMware Fusion or Parallels, or you can use this UTM. Okay, this UTM is free and it is available for you to download on GitHub. I will provide the link to the description on how to download this UTM. And basically you can follow the instruction on how to install Ubuntu machine, Ubuntu VM, or maybe even a Windows 11 machine in your M1 machine. Okay, so this Ubuntu run using the ARM64 architecture. It is run using the virtualization. Okay, and that's it. Now let's begin and start coding. Don't forget you can clone or download the completed project GitHub repository from the link that I have provided at the description. Okay, to begin, let's install the required dependencies, which is the LibGD. So LibGD is an open source library that is available on macOS as well as Ubuntu. So it can be used to manipulate image. If you can see in here and about. GD is an open source code library for the dynamic creation of images by programmers. Okay, it has built-in support for GIF, PNG, JPEG, HEIF, TIFF, and so many more. Okay, we are going to install this using the package manager in Ubuntu as well as Homebrew in macOS. Okay, let's begin the installation from the Ubuntu. So to install this GD in Ubuntu, you can use sudo apt get install libgd and then -dev. Okay, and enter your password. Okay, I already installed it here, so it doesn't need to download it. Okay, so this is how you install the libgd on Ubuntu. And let me show you on macOS. On macOS, you need to install the Homebrew package manager first, and then you simply type brew install gd. Okay, this will install the libgd for macOS. Okay, I already installed it in my case. Okay, so after we install the GD, we should be able to use this in our command line tool. And so in my Ubuntu, I'm going to create a folder for the project. So here in the home directory, I'm just going to create a directory app icon gen. Okay, and let me navigate to the folder. And here we are going to create a new SPM package. Make sure you have installed Swift in your Ubuntu virtual machine by following the instruction from swift.org download, and make sure you have added your environment variable to your path. Okay, and here I can create a Swift package by using Swift package init, and we need to pass this flag type, which is executable. We want to make our package executable. Okay, it has created all the sources, all the package.swift. Let me open this using Visual Studio Code in Linux. Okay, this is very similar to Visual Studio Code on the other platform as well. And basically in here, first make sure you install this extension, this Swift extension, Swift Server Workgroup. This is required for the code completion to work in Linux. When you install this, it will also install this code LLDB. Okay, so after you install these extensions, make sure you close and then reopen the Visual Studio Code to make it work. Okay, and we have the package.swift file, and also here inside the source we have this main, and basically we can also use the debugger in here. So let me put a breakpoint here, and then you can click on this run and debug. And to debug, you just select this debug app icon gen and then click. Okay, as you can see, the breakpoint stop, and basically we can inspect any variables here, local, static, global. Okay, so that's basically on how we can debug in Linux. It's very simple using the Swift extension for the VS Code. First, let's begin by modifying the package.swift. So we need to start by adding the platform that we are going to support. And in here, we just need to add macOS. And let's pass macOS 12 because we are going to support async await, which is only available on macOS 12. And for Linux, we don't need to pass Linux in here. We just need to pass macOS for the platforms. And for the dependencies, there are two dependencies that we are going to utilize. The first one is this Swift Argument Parser. So this will help us to create a command line tool app using this argument parser. And let's see how we can install. Okay, here we can just simply copy this and let's go back to Visual Studio Code and okay, let's add this as the dependency. And let's use the 1.1.0 release. This is the latest one. And the second one is SwiftGD, basically a Swift wrapper for the GD library to interface with the GD library. And it is made by Paul Hudson. So let me go to the address here, SwiftGD. Okay, kudos to Paul for creating this amazing wrapper for LibGD. Okay, for the installation, let's copy this and add this as the dependency. One of the dependencies. Okay, so these are the two dependencies, and we need to also add this into the executable target, this app icon gen. Okay, so the first one is using this product, and let's pass name and argument parser. The package name is Swift Argument Parser, and the second one is SwiftGD as the name, and the package name is same, SwiftGD. Okay, these are the dependencies that we have added. Let's save this, type Ctrl S, and this will automatically try to resolve all the dependencies. Let's see anything that we miss in here. Okay, I think we need to add comma in here after the platforms. Okay, now it fetches the Swift Argument Parser as well as SwiftGD. Nice. And basically in our app now, we can simply import argument parser and SwiftGD. Okay, I don't think the code completion works, so if this happens, just close your VS Code and then open it again. This usually happens. It's not stable yet. Okay, let's try. Okay, now the code completion works here. And let's try to build first, Swift build. Okay, it still failed to get the argument parser. Okay. Okay, now we have imported the argument parser and the SwiftGD. Let's start to begin by creating all the models and all the service that we can reuse from the previous project. Okay, so now let me open this SwiftUI App project, SCA icon generator. And for the models, let's try to copy this. So inside this source app icon gen, create a new folder, give it a name of models, and the first one is app icon.swift. So let's open this. Okay, so remember this XA icon generator SwiftUI app is also available from the GitHub for you to copy and paste, so you can follow me in this video. And please remember, you can always watch the previous video if you want to learn more on the background on how we build this. Okay, you can just Command A, Command C, and then paste this. Okay, and now we don't have UI kit on Linux, so we need to delete this. And what else? For the IDM, which role and what subtype, we can just create a new file, enums.swift, and open this enums.swift file as well from the XA icon generator. Command A and Control V on Ubuntu, and make sure to save this. Okay, now let's try to build Swift build from the terminal. So you can toggle this terminal by pressing Control tilde. Okay, Control tilde. So this will basically provide you with a shell terminal. Okay, Swift build. Okay, everything works now. I don't know what's still giving us. Okay, now it works. Previously it showed the error there. Okay, now we have the app icon, the enums, the models for this app, and we can build it successfully without any modification. Next is the services. Let's create a new folder here inside the app icon gen, inside the sources, services. Let's take a look at the services. Okay, this one, icon resizer service. Yeah, let's try to copy this. This will fail eventually because this depends on UKit, so we need to make some modification so it works on Linux without any dependency on UIKit. And in the services folder, create a new file, give it a name of icon resizer service.swift, and Command A and Control V. And now let's see here. Let's save this. Yeah, it will fail. UI kit is not available here. So now let's change this UI image to use the SwiftGD image. Okay, now we can import SwiftGD. It will be available both on macOS as well as on the Linux here. So let's use this image. Change this also to image. Okay, and basically in the icon resize data, we also need to pass an image instead of UI image. Okay, and icon resize data. Okay, so we need to modify this because we don't have this image by preparing thumbnail. It is not available on this SwiftGD. It has different method for resizing the image. Okay, so let's first, I think let's comment the code instead of deleting it. Okay, let me comment everything here. And as you can see, this is an async function. So to make this multi-threading, I think the SwiftGD method in here we can use the Resize to passing the width and height. But as you can see, this method is synchronous, and this will block the thread. We don't want this. We want everything to be async. Okay, so let's just use this try wait. Okay, and use this with checked drawing continuation. Okay, let's provide a closure containing the continuation as the parameter. And the first one is this. Let me add a parenthesis here. Okay, the type is checked continuation. It has two generic that we need to provide. First is the return, the app icon, and the second one is the error. Okay, but we need to use shift error. Okay, because SwiftGD also has an error, it will create a build time issue. Okay, so in here I just explicitly say I want shift.error. Okay, I think I missed the closing parenthesis. Okay, and now let's continue with getting the size. I think we can just use this. So let's cut and paste this. Okay, we have the size, which is the app icon.point multiplied by app icon.scale, and this is a square icon. So we can use the same one with the height. Okay, after we got the size, let's just use this guard lat thumbnail. In here we can simply use image size to passing the size dot width as well as size dot height. Okay, and this is a CG float, so we need to convert this to integer because this image has to accept an integer. Okay, integer. Okay, we cast this to from CG float to integer. So after we got the thumbnail, let's grab the data. Okay, let data, and we can convert this SwiftGD image to data using try thumbnail. So this is export as, and going to pass PNG as the format. Okay, and basically in the else I just throw an error here. So with the continuation, we need to call continuation.resume. In this case, we want to throw an error, and let me throw this ns error. Okay, the domain, let me just put XCA code 1, and for the user info, ns localized description key. Here I can simply pass failed to generate thumbnail data. Okay, so this is in case of error, in case it fails to generate this thumbnail as well as the data, and make sure to return. Continuing on, we need to invoke continuation.resume and passing the app icon. So I think we can copy this code, Control X, Control V. Okay, and let's remove this old code and make sure we the data, make sure we pass the data. Okay, now we have this icon resizer service. Now it works using the SwiftGD instead of UIKit. Nice. Let's move on to the second service. Okay, so for the next service, let's move the file icon service protocol. Basically, this will be managing on creating all the files and saving it to a zip. Let me copy this file icon service. Okay, For sure this will break because this ns file coordinator is not available on Linux. Okay, Control V. Okay, ns file coordinator is not available here. And also we have to change the parameter in here, because if you remember from the command line tool, we can pass the export path, the safe location as the argument. So that is different compared to the iOS app where we just generated the URL and the zip and then we just export it directly, right? And for example, in UI kit, we are using UI activity view controller, and on iOS, we are using a document picker. Okay. But on this, we have accepted the user input first. So we need to process that export path given by the argument and then save the file to that export path. Okay, so first let's remove the coordinator, and also for this archive temporary directory to URL, we need to pass the path, the export path here. So let's change. Okay, let's also update this inside the implementation. Control V. Okay, and now we need to change the implementation here. Instead of using coordinator, we need to use a shell command, a bash command or zsh command. And to run a shell, we need to create a utility tool here to basically invoke the bash or the zsh on Mac and pass the argument. So with that, we should be able to invoke any shell command in Unix, right? Just like zip or env, cp, or any kind of modification in Unix file system. Okay, so here inside the app icon gen, let's create a new file and give it a name of utilities.swift. Okay, now I'm going to just copy and paste this. I'm going to make this as a global method. Okay, give me a second. Control V. Okay, and let me import foundation. Okay, so let me explain it to you. So here we initialize the process, a new process, as well as the pipe, and we set the standard output and standard error to use this pipe. And here we pass this argument flag C and the command that we are going to pass when we invoke this. And here, in case the operating system was Linux, we are going to find the default shell. In case of Linux, it is using a bash shell. And in case of macOS, with the recent release of macOS, they are already migrated to using this CSH as the default shell. Okay, and basically we just invoke run to run the command in the shell, and we grab the result from this pipe and save it to this data, and finally we convert this data to a string and then return as an output. That's basically it for invoking shell command from the Swift app. Okay, and now we can use this inside the file icon service protocol. So here, when we archive this temporary directory to path, we need to basically construct the shell command to manipulate the file. Okay, let me just, so I need to wrap this. This is a throwing that save shell. Okay, catch, and then in case of fail, let me just print. And as this is inside the continuation, I need to invoke continuation.resume, passing the error throwing, the throwing parameter. And in do, I need to put this into constant result and then invoke tries shaft shell. Okay, for the command, I'm going to use a Swift multi-line string. Okay, and external argument label command into source. Okay, we don't need to pass this command as the argument. Okay, now we can just provide the shell command from here, right? So the first thing that I want to do is I want to remove the file from this export path. Okay, just make sure there's no conflict. So rm -rf path. Okay, let's use the interpolation path /app icons dot zip. Okay, we remove it from the path. If there previously there's an app icons dot zip in that path, we are going to remove it, clear it, so we can avoid any conflict. And second one, we need to grab the current project working directory and save it in a variable using this pwd equal, and then add this two apostrophes, maybe, I don't know. Okay, this is the symbol, and now we need to also pass pwd. Okay, and we have saved the project working directory where this command line tool is invoked. The next one is we need to navigate to the temporary directory. .path. Okay, so we are going to generate the zip file inside this temporary directory. Okay, and this will be random each time of the invocation. Okay, so inside this temporary path, we're going to invoke zip and passing this r as well as this x. This x, make sure when you run this on a macOS, it doesn't store the macOS, any macOS related file such as macOS or dstore. Okay, and next we are going to pass the name of the file, which is appicons.zip. We are going to save it in this directory immediately. Okay, and as you can see in here, inside this method, it already saved all of these files into this temporary directory /appicons. Okay, so inside this cd file manager path, there must be this appicons folder. Okay, so that folder, that's the folder that we want to zip, that we want to archive. Okay, and next, after the zip is created, we cannot simply use this. So you may be wondering why I navigate to this temporary directory path, right, instead of just passing it in the zip, right? So if I do that, when I try to unzip, the result will be like this. So this is the temporary directory. This is quite nested, as you can see. Okay, so to avoid this, I need to navigate to this directory before the applicants directory in the temporary directory, and then creates the zip file from there to avoid that nesting when unzipping this. Okay, yeah, this is quite a bit complicated, but please bear with me. So after we zip this, now we need to move the file, this appicons.zip, to the pwd using this $sign. We already saved this as the variable. So this basically will move the appicons zip inside this temporary directory path to this pwd where the command got invoked. Okay, now let's navigate back to the pwd directory. And so basically, if the user passed the relative path, probably dot or slash, which is the current directory, we need to be careful because the file is already in here. So we need to add a check here, private func. So let's give it a name, export path current directory. Okay, with the parameter of path string and return type of boolean. So basically the user can pass anything, right? They can pass this is a relative directory, right? But if they pass the current relative directory, such as this, sorry, let me, or path equal to this, or path equal to this. Okay, this is the current directory. So in this case, we don't want to move that to the path passed by the user. Okay, because we already put this inside the project working directory, which is the current directory. Okay, so in here we can simply invoke is export path current directory, passing the path. So in case export path current directory is false, if this is false, we are going to invoke mv app icons.zip and the location where we want to export this. Okay, and in case of this is already in the same directory, in case either of this dot slash or dot slash, we don't need to do anything. Okay, because the file we already move it to this directory. Okay, this current directory. Okay, it's a bit complicated, but yeah, please bear with me, and you can try to understand this step by step and try to modify it step by step. Maybe you can find another better solution instead of this complicated solution. Okay, and but actually this is works, and let's continue and let's print the results. And finally we need to invoke continuation.resume, and in this case we already know the export path, so I don't think we need to return anything. So let's remove this and let's just return void. Okay, did I miss? Oh, okay, sorry, I missed this opening braces. Okay, now we have implemented this file icon service protocol. I think this is the last step, and the next service will be very simple to implement. Okay, now let's try to run Swift build, make sure there's no problem. Okay, no problem. Now let's create another Swift file inside the service, which is the, let's check, the icon file generator service .swift. So this will glue all the code inside the file icon service file icon service and icon disaster service. So let me rename this. Why I give it the name of protocol? Okay. Okay. Now inside the icon file generator service, let's copy from this. Okay, it uses UI kit, but we can simply change this. Control V. Okay, let's change this to SwiftGD and let's replace this image with the SwiftGD image, and we need to pass the path. Remember, the export path should be a string. And let's pass SwiftGD image as well as the path. Okay, as you can see, this has this file icon service protocol as well as the icon Resize service. So first, it's going to just clear everything, the existing temporary directory URL, to make sure there are no conflicts. And in here, it just loop this app icon type. This can be iOS or iPhone, iPad, Mac, or Apple Watch, and it will generate the assets, resize all the icons required for that app icon type, and it will save it to a temporary directory folder. Okay, and basically in here at the last we need to archive this, and we already updated this method to use this archive temporary directory to path. So we need to pass the export path. Okay, I don't think we need to pass the path. Okay, okay, and in here we don't need to return the URL, so let's remove this because we already know the export path. It's given by the user, right? So let's just invoke try wait without any return. Okay, now we have this, right? We can start the integration, inside the main.swift. Before we implement the argument parser, let's try to just test this, okay, by hard coding the value. Okay, so in here, let me just do this. So as this is a async task, we need to trigger this task.detach to switch to async task. But because it runs on the command line, we need to use this run loop. Let me import foundation first. Run loop dot main run until distant feature. If you don't call this task.detach will never get executed. Okay, it will just exit the program. And inside this task.detach, let's just declare do catch statement in here. And I think let's just grab the image, image. In here we can use the SwiftGD URL, file URL with path. So for now, let's just hardcode this to icon.png. So this is the directory where this gets executed. We are going to copy this icon.png here. Let me remove the dot. And basically in here, we need to, sorry, I think I need to change this to location instead of image. So this is the URL location, and then that means guard image. We can just initialize the image passing the URL, just this location. Okay, so in the else we just give a file error. Image failed to initialize. Please provide a valid image file. Okay, and then in the do, we can simply invoke icon file generator service. Let me initialize this icon file generator service. Let's just pass file icon service as well as the icon Resize service. Okay, now we can simply, let's print error .localize description, the catch block. And then in the do, basically we can invoke try, await, and icon generator service. So let me change this to a lowercase, the prefix. Icon generator service dot generate icons URL for app icon type. Let me pass iPhone and iPad, Mac, and Apple Watch. And the image, we can simply pass the image. And for the path, let's pass the current directory where this gets executed. Okay. And let's try this, right? But first we need to copy an icon image and give it a name of icon.png. So for me, I'm just going to already have this icon.png. Okay. So let me copy this from the completed project, icon.png. Okay, now I have icon.png. And before we can invoke this, first let's go to the, let's just use VS Code terminal instead of this. Let's use Swift build configuration release. Okay, so this will trigger the release build instead of a debug build. It will remove all the symbol used for debugging. Remember that production build, it will be faster compared to a debug build. Okay, even on any iOS or macOS app. And here we can use this build. It will put the release to this build release, and I have icon gen. Okay, let's enter. Nice. Is it working? That's ls. Okay, I can see the ls icons.swift. Yeah, I think it works. So basically in here, in this one, it just stopped, right? Because in here, this is a run using a until the destined feature, right? In here, probably we can exit to end this. Okay, let's open this app icons.zip and extract this. Yeah, let's extract this here. App icons, iOS, Mac, and Apple Watch. Okay, looks good. All the icon set for iOS, Mac, and Apple Watch. So it works. Now let's move on to build the command line tools using the Swift Argument Parser. Okay, so now let's build the CLI tool using the argument parser. Let's open the argument parser GitHub. Okay, so in here, if you want to take a look inside the documentation, there are three items in here that we can use: the documentation, getting started with the argument parser, and parsable command documentation. The easiest one is just to use this getting started with argument parser. So this is an article that basically provide a simple example on building the command line tools. So if you take a look in here, we just need to create a struct and then make it conform to the parsable command protocol and set it as the entry point using this main keyword. And in here, to add an argument, we just use this argument property wrapper and define the name as well as the type. So if you see in here, there are two arguments, input file and output file, which it is passed here. This is the input, this is the output. Okay, and let's continue. So adding a flag, right? So using a argument parser, we can also add a flag. In this example here, it has this verbose flag. So in case it is verbose, it's going to print the word in the console. And when this is being invoked, we just need to pass the flag using this dash flag name. Okay, and this will be considered as an option, argument option. Also, if you also want to pass argument options other than the flag, for example, this input file in here, it needs to use this dash input file and then provide the value. Okay, in our case, we just need to use the arguments and the flags. We won't use the option. Okay, but that's how it works. Also, it has some convention in here basically that can be customized. I think by default it's going to use the short long as the name. So here's going to use dash input dash file, but this can be customized using this parameter. We can pass the custom name for the parameter. And also in here, we can also provide a help for each of the argument argument option, flag, or arguments. Okay, and we have this configuration that we can define to provide an abstract for this CLI tool, as well as the how this can be used, as well as the usage description. Okay, so without further ado, let's just implement this. Okay, go back to VS Code. Now we don't want to use this main Swift as the entry point of our app. So in this case, inside this app icon gen, I'm going to create a new file. I'm going to give it a name app icon gen.swift. And in here, I'm going to import argument parser, import foundation, and import SwiftGD. Okay, and I'm going to use this main as the entry point, and I'm going to declare a struct app icon gen that conform to parsable command, right? So when you conform to parsable command, you need to implement this run, right? But if you see, this run runs on synchronous context. But in the case of our function here, it runs inside an async context, because this method is an async await method, right? This icon file generator generate icons URL. So luckily, Apple provide the async parsable command, which we can use for async context. Async parsable command. So in here, we need to implement this run async. Okay. So as you can see, this async runs in the asynchronous context. Okay. Now let's just try this. Hello. Okay. And for now, we can, let's copy this. Okay. Control X, and then let's put this here. And then for now, let's comment this. And let's just delete the main.swift file. Move to trash, save this, and let's try to Swift build configuration release. And let's invoke this dot build release app icon gen. Okay, if you can see here, it runs this run method. Hello, it's being printed in the console. Okay, now we can use this, right? First, we need to declare the argument that we are going to use in our app. The first one is argument, using this argument property wrapper. And let's provide a explanation, input image file path. Okay, and here we're going to give it a name of input image path. Okay, with a type of string. This is the first required argument. Second one is help the export path. Give it a name of export path with a type of string. And next, let's declare a flag. Okay, this is a flag. So this should be a boolean, and for this flag, I'm going to use this all false with the default value of false. So when the user passes this all as true, we will generate the icon sets for all the platforms: iOS, containing iPhone, iPad, as well as Mac and Apple Watch. Okay, let's provide a help in here, and passing this flag will overrides all the other flags. Okay, so for the other flag, we want to also give the user to an option to generate only for specific platform. Second one is flag, and we're going to pass iOS, false. Let's provide a help here. So let's say generate iPhone and iPad icons in single iOS folder. Okay, now let's add the flag for iPhone. And here we need to be careful, right? Because if we use this iPhone by default, it will make it like this as the argument flag. Okay, so to handle that, we can use this custom name. In this case, we are going to pass iPhone explicitly as the argument flag. Okay, so it doesn't use this. It looks weird, right? And copy this. This one is iPad. Okay. And next is Mac and watch. Okay, all the values, default values for the flag are false. Okay, now let's implement the logic. We have all the parameter, right? So if you try this, right? Let's try to build this, run this. Now when we run this, right? When we use this dash dash help, it will provide all of this. Okay, explanation. Look at this iOS. This is a bit weird, right? Because the O is a large capital case, right? So we need to also use a custom long name for this. Name custom long. Let's pass iOS. Okay, now looks good. Okay, now let's continue to the run. Can now implement this. Let's just cut this, put this into the run, and remove the comment. Okay, let me fix the indentation. Okay, now we got the location. For the location, we need to pass the argument option, the input image path in here. Okay, and as simple as passing this export path, that's it. This should works, right? But we have to also implement the logics for this flag, right? So in here, I'm just going to copy and paste this, right? I don't want to make it too long in here. Let me copy this and let me explain it to you. Let me hide this terminal. Okay, so first we declare the app icon type property with an empty array of app icon type. So if all is true, so when the user pass this all, we're just going to pass iPhone and iPad, Mac and Apple Watch. And then here, in case no, all is false, we're going to go to this else block. And here we're going to check if it is iOS. We're going to append iPhone and iPad, and we're going to use else if. Remember, these three are interconnected, okay? This will go into a same single folder iOS. And second, if only iPhone is selected, we're going to append iPhone. And if iPad is selected, we're going to append iPad. Okay, this should handle all the iOS generation. Next, if Mac is true, we append the Mac. And finally, if Watch is true, we append the Apple Watch icon type. And finally, if the user doesn't pass any flag, this app icon type.count will be 0, right? Because this won't be executed, right? And in this case, we're going to just export for all platforms. Okay, as simple as that. And also we need to make sure in here we need to change this. Okay, this is currently hard-coded. Let's pass the generated array. Okay, now let's try this. Okay, save build configuration release. Okay, and build released app again, app icon again, and then let's pass icon.png as the input, and let's save it in the desktop. Okay, then let's not pass any flag. It doesn't, you don't have any permission. Maybe I need to use sudo in here. Okay, now it works. And let's check the desktop. It should generate this icons.zip that contains all the iOS, Mac, and Apple Watch. Okay, this works. And let's try to pass a single flag, watch, maybe a double flag, watch and Mac. Okay, now let's open it again. It should only contain 2 folders, Mac and watch. Nice, the flags work perfectly. And yeah, I think with this we have successfully built this command line tool for the app icon generator that works on Ubuntu Linux as well as macOS. Congratulations on completing this tutorial. And as you can see, this argument parser is very powerful, right? This abstraction is very powerful. You don't need to handle this kind of thing by yourself, right? So you just need to use this property wrapper, and basically Apple will handle it for you. So let me just show you one final example here. I passed this as static configuration containing the explanation of the application, this command line tool. And when I want to use this, basically I just, when the user want to use this, they can just use this icon gen -- help, right? And basically it will provide all the information, this overview, and as well as this usage. Okay, so if you want to modify this overview as well as this usage of the command line tool, you can use this command configuration. Okay, static configuration, command configuration. So this is a very simple usage of this argument parser. I think this argument parser has a more complex feature, which is maybe using a nested command. If you have any kind of use case for your app for that complexity, this argument parser should handle your needs. Okay, so that's all for this video. Please download the complete project from the GitHub repository if you want to check the source code or if you encounter any issue. And please give a comment and feedback inside the comment below. If you want to learn about something, you can maybe provide a recommendation that maybe I can take a look and probably create a video about it. Okay, and let me know if I make some mistakes and correct me in the comment below also. Okay, and that's all for this video. Let's keep being on a lifelong learner, and until the next one, goodbye.